Hey, everybody. Thank you for being here. Thank you for coming to my session. What I'm going to talk about is Batfish, which is an open source network validation solution that we and many others in our community have helped build over the years. And we're going to talk about how we can use that to test for and prevent BGP route leaks as you're making changes to routing policy and configurations. So what I'm going to do, give you a brief overview of what is Batfish, how we get started, what you can do with it, and then I've got a couple of live demos that I'm going to walk you through to show it in action. So in terms of Batfish, what is it? It's a pre-deployment network validation solution. So the genesis of Batfish was actually a research project at Microsoft Research back in 2012. The story was Microsoft wanted to know, is there a way to validate configuration changes before you make changes in the network, before you push them to the network? Just like you can validate software changes you're about to make to your code base, that's just like you validate changes and designs of hardware, FPGAs and ASICs. Can we take some tools and techniques similar to that and apply it to the network, with the network config being the language you're analyzing? So that started back in 2012. Batfish as a project in open source land came to be in 2014 under Apache 2 license. Since then, we've got a growing community of users and contributors to the code base. And then there's a commercial part of it from IntentionNet that's being used in multiple networks today, but that's not the topic. I'm going to talk really about, show you how you can use the open source part, open source Batfish, to validate network changes, specifically for BGP. So the design of the system, the way Batfish works is you feed Batfish the configuration of your network. So firewalls, load balancers, routers, switches, cloud instances as well. So it can be AWS config with VPCs and transit gateways and peering. All of that gets ingested by Batfish. So there's a pretty wide list of supported vendors, and that list continues to evolve and grow. So as we interact in the open source or the enterprise world with more customers, we see more networks, we add support for new config constructs and new platforms. So what happens under the covers is Batfish ingests those configs and builds a series of network models. There's three primary network models that we build. The first is just a vendor-neutral configuration model. So we take the vendor syntax config and we normalize it into an internal data model that allows us to sort of easily build a sort of analysis toolkit on top of it. So we sort of normalize, Juniper might call something a firewall filter, Cisco calls it an input access list, we call it an input filter. Similar, just trying to normalize the construct so that we can build our analysis on it. The other core piece of the technology is a full routing and forwarding simulation. So one of the unique things about Batfish and its core is, based on the device configurations and the models that have been built and encoded in the code base, we build the routing tables and forwarding tables for every VRF for every device in the network that you've uploaded into Batfish. And that is sort of a core piece of the analysis that allows us to do things like BGP policy validation and reachability validation. And the third set of models are what we call sort of mathematical models of network behavior. So we take the device configs, we take the routing and forwarding tables, couple that with the forwarding pipelines and the routing pipelines we've built inside the system, and we create a series of equations that describe the behavior of the network so that we can understand how packets will flow through the network. So we don't need to generate every packet type to tell you what packets can get from one subnet to the other. We can solve an equation to say, okay, these are the packet headers that are allowed to traverse the network from this point to this other point. So that's what these mathematical behavior models do for us. That all couples with a series of analysis engines under the covers. And all of this, by the way, there's a research paper that was published in NSDI, and there's a follow-on research paper. So the underlying algorithms and architecture for each of these components is sort of well documented there. And you can get all of that through the batfish.org website. But the way you interact with it as a user is you can query the Batfish engine and extract information from the different data models that it's created. So from the vendor-neutral config model, from the routing model, from the forwarding behavior models. And so you interact with the series of queries or defining a set of policies that Batfish will evaluate for you and tell you if the network is going to violate those policies or not. So from a category standpoint, there's four broad categories of queries and policies that you can interact with Batfish from. So one is just configuration audits. So things like, are your device compliant to a certain site standard? So does everybody use the same NTP server? Does everybody have the same DNS server configured? Then you can do analysis on protocol sessions. If you got IPsec tunnels into the cloud, do I have key pair matching between my on-prem and IPsec endpoint and the cloud endpoint? Or is my MLAG configuration correct? Is my BGP session configuration correct? To make sure these sessions will get established. So you can sort of audit the config without looking at the behavior. Then you can also do sort of standalone firewall and ACL analysis. So without building the full routing table, we can help you understand what packets are going to be allowed through a firewall, which packets are going to get denied, when you make a change, how that change is going to impact the flows that are permitted or denied through the firewall or the ACL. The third category, which is sort of what the demos are going to focus on, is sort of the routing and forwarding analysis. So you can query Batfish to understand what is the impact of a link failure or a set of link failures. Will any services be disconnected? So are there any flows in the network that were previously carried that now, because I failed one or two or multiple links, that are no longer carried in the network? And then what happens if I make a change to my routing policy? So if I make a change to a BGP routing policy, or if I make a change to how I'm redistributing routes from OSPF into BGP, what does that do to the overall forwarding behavior of my network? What does that do to availability and serviceability of the different services that are running there? And then you can sort of aggregate all of this into sort of a comprehensive reachability analysis where you can have rules or policies and queries around, show me who can reach this subnet. So, you might have a protected segment. So if you're doing microsegmentation, you might want to know, make sure there's nobody that can get from my PCI zone to my non-PCI zone, or make sure nobody can get from subnet A to subnet B except for SSH traffic or HTTPS. So all of these things, queries can be encoded and expressed in Batfish. And then you can understand every time you make a change, what is different about the network in regards to these queries and these policies. So if a change is going to violate one of these policies, Batfish will flag that for you so you don't push that change into your network. So I'm going to switch gears. I'm going to show you a couple of live demos. The first demo is just going to show you how I can use Batfish for automatic policy validation. The second one's going to sort of show you how you can analyze a simple sort of route policy change. And the third one's going to put this all together and say, okay, give you a hypothetical scenario of a routing policy change you want to make and how it could result in a route leak, and then how you can catch that with Batfish, what you would look for, and then how you can prevent that from being deployed in the network. So demo number one, this is our basic network scenario. I've got a small network. I've got two peering devices. I'm talking to two different customers. And what I want to do is I want to validate my policy towards these customers. And I want to build a vendor-agnostic test suite out of it. So I don't want to have to write something specific for a Juniper Edge device versus a Cisco device versus a Cumulus device or an Arista, whatever it might be. And a lot of these tests are sort of inspired by what the manners community has put together in their guidelines. Like they have, a robust set of tools that they want people to use as they're building BGP routing policy at the edge. And so working with them, we've turned those guidelines into a series of policies that Batfish can execute for you every time you are looking to make a change to that peering config. So let's take a look at one of these. So again, don't worry about trying to read the code. Everything that I'm showing you here is on a public GitHub repo. And towards the end, I'll show you the link where you can download all the code and play with it, and then the instructions on how to use Batfish. So here, what I have is I have a policy that's wanting to make sure something simple, that I don't ever configure a BGP session to a customer that doesn't have an input policy. Seems like a pretty basic thing you'd want, easy to encode and write in Batfish in a vendor-agnostic way, so you don't have to worry about, again, the differences of how vendors express policy and how they attach policy to peering sessions. So let me go and show you that in action. So what I'm showing you here is I'm using a series of Jupyter notebooks. So the primary way you interact with Batfish is through a Python SDK. And these Jupyter notebooks give me a convenient way to run Python code in this environment and sort of show you what we're doing. So here's my demo network. As I'd shown before, 2 customers, 2 PEs. To get started with Batfish, there's a very simple sort of setup. There's a couple of API calls that just sets up your connection to Batfish and uploads the config. So this init snapshot call is just uploading a set of device configs for those 4 devices I had and telling Batfish, start analyzing it. So we've built the snapshot. Batfish has built its data model. So what this is just a simple query of the routing tables. So what I'm trying to show you here is like, hey, let me see the routing tables for PE1. I have a simple Batfish API call that I can make that does that. And to show you that this is truly a live demo, I can run a different question. And I don't have PE3 in my network, so of course there's no routes. But if I was to look at PE2, I can see I have a series of routes. I just showed all of them, but let's not scroll through them all. But again, it's very easy to extract any information that Batfish has computed. There's an API call that allows you to extract that. The most common output is a table format that you can then integrate in any sort of automation workflow you might have. So how do I turn this into a series of policies? How do I check policy? So the common way we sort of recommend people using Batfish to interact with it in an automated CI/CD pipeline is to use something like a test framework like PyTest. So I've built out a series of policies in Python using PyTest, and I'm just going to run that. And I can call that from here where I'm just running PyTest from the command line, and it's going to generate a report for me. And that report is going to look like this. So I have a series of policies that are defined. So all in all, I have 15 policies that are defined. 5 passed, 10 failed. And I can go through this report. It's going to tell me more about why I had certain failures. So let's pick on the first failure here. Test no undefined references. So this is telling me, hey, on my PE device, I'm referencing a route map for my BGP policy, but I haven't defined that route map. So I'm not going to have the behavior I'm expecting. So even though there's that line in the config that says BGP output policy route map foo, in this case, you're not going to see any impact for that because it's not defined. And so this is an easy way to catch that. A more sort of interesting one would be, let's look at a test for advertised long prefix. So I want to make sure my customers are not allowed to transmit prefixes that exceed a certain prefix length. So I've decided it's /24 is the limit. This is going to find anytime there's a route that they're sending me that exceeds that, I can tell you if that's the case, and that's a violation. Now, in this scenario, I could also make a test that says, it's okay if they advertise it, it's just not okay for me to accept it. So I'm going to make a test to make sure that I don't accept that. And then there's other things I can test to make sure, if I expect to see communities on routes that I receive, so if I have an appearing agreement that says everything must be tagged with a set of communities and the specific defined communities, I can encode that as a policy, and so on and so forth. So any behavior you think you want to encode from a networking standpoint, from a routing and forwarding standpoint, you can turn into a series of policies and have Batfish analyze that every time you go. And as a part of a CI/CD pipeline, this PyTest framework will generate a report and then let you sort of prevent pushing changes to the network that would violate those rules. So very sort of quick demo there. So let's go back to our slides. So now I want to show you just that same sort of demo network, how do I analyze a routing policy change? And what are the sort of Batfish constructs I can use to see if a policy change is going to have the impact that I expect it to? So here I have a policy that I've defined for my peer to customer 1 on PE1. And this over here is letting everything in. So I'm blocking bogon routes, and then I'm saying, okay, I'll accept anything else from you. So let's say I want to amend this policy, and I don't want to accept anything greater than /24. So I want to make that last policy run that was non-compliant now be compliant. So I'm going to update my policy to block anything that's greater than /24. And now let's sort of take a look at what that means. So there's a multi-step process that goes into evaluating a change. The first one is I want to collect my BGP adjacency ribbon. So there's multiple ways you can do it. You could use OpenBMP. So if you have an OpenBMP server where you're collecting that information from your peering, you can feed that into Batfish. We can parse that and build that into the model. You can collect that through a series of show commands. A lot of the vendors will let you do show IPBGP received routes or some command of that nature that'll let you see exactly what your peers are sending you. So you can, again, feed that into Batfish. And then you upload a snapshot. So the snapshot is the config and the BGP rib that's currently there and the proposed change you want to make. And then there's a series of Python APIs that allows you to evaluate it. So I'm going to show you what those look like. So got my demo network. I'm going to analyze my policy on PE1 towards customer 1. And a little smaller. So this is just sort of setting it up. I'm telling Batfish, okay, I care about PE1, this specific peer, and then I'm going to retrieve the policy. And now let's look at what the BGP adjacency rib is. So I've fed that into Batfish. Now I'm going to retrieve that, and I'm going to send that into my policy evaluation. So the core query you're going to use in this environment is this query we call test route policy. So in Batfish, if you take the test route policy question, you identify a peering session, you give it the routes that you are expecting to get from it, and the policy name, it'll tell you what that's going to do. So it's going to give you a complete evaluation of what the routing policy is going to do to those incoming routes. So you can see which routes are being denied. So in this case, that policy in its current form is not denying any of the routes that I've received from the peer. And then I can look at which routes are being permitted. So I see a series of routes that are getting permitted. I'm only showing the first 5, but there's a lot more there. But it also tells you how it's transformed. So it's not just, did I send it yes or no, but what is my routing policy going to do to that route? How am I going to transform it? Am I prepending AS paths? Am I changing community values? Am I changing local pref? Any of those BGP attributes that are being defined in the policy, you can see what that impact is by looking at this query. And then I can look at routes that I'm receiving, but I'm not modifying. So there's nothing that's coming in that I'm not touching or tagging in some way. So that's a good indication that the policy is doing something. So now let's change the policy. So I'm going to take that same policy I was showing you earlier around blocking my /24 prefixes. I want to see how I can analyze that with Batfish. So the way to do an analysis on a change is, rather than feeding in the entire configs, we have an API that lets you fork a snapshot, saying, okay, this is the base snapshot, this is what's running in my network today, here's the change I'm going to make, here's the delta. So just feed in the delta from your base, and then Batfish is going to recompile, it's going to build the full forwarding tables, the routing tables, and tell you, let you run interesting queries against it. So real quick, the config change. So what you see here is I've added this prefix list block 24. I've updated my route map, added a deny line for sequence 10, and then I've changed the sequence numbers and the rest of it. So let's see what this does. So now I've written some code that takes the core Batfish, and now it compares the routing policy evaluation between what was running in my network versus and the change I'm about to make, the change I want to see happen. And so now I'm going to interact with that. I'm going to extract different pieces of information. So find new routes that are denied. So from the routes that were being fed in from my peer and the change that I just made, I'm going to deny the /26 that I was previously accepting. And then I can see if I'm denying anything that was, permitting anything that was previously denied. So I can see that nothing else has changed. So I'm not adding more prefixes into the mix. And see if there's anything that's just being accepted but not modified. So that's not the case either. So just using a couple of these steps and a couple of queries, I can understand exactly what a routing policy change is going to do for me and make sure that that's exactly what I want. So I can inspect that in advance, and you can do it in sort of a vendor agnostic way before you push it to the network. So you don't have to push it to your device and rely on box analysis from vendor A or B to see what the impact of a routing policy change is going to be. All right. So the last sort of demo I want to show you is a little more, it sort of builds on the other ones, it's a little more involved, is how do I now look at this and say, okay, I want to make a change. I know it's going to permit certain routes, but I want to make sure I don't leak it. So this scenario I have here is I want to accept certain longer prefixes from a peer because they want to load balance traffic to me, but obviously I don't want to provide that as transit to everybody. I don't want that to leave my network. So I don't want that to leak into the rest of the internet. So how am I going to evaluate that? What's the process I could use to make sure that I can make a change safely and not leak that route to adjacent peers? Again, it starts with collecting that BGP adjacency ribbon. So that's sort of your starting point. You have that data, you know what your peer is sending you, and now you can sort of analyze changes to the network to see how the changes impact the routing policy and how the end route tables. And then you sort of rinse and repeat until you get the change in the scope that you want it to be. So you accept the routes you want to, you transmit the routes you want to, and nothing else. So in this example, I have, so in this network, ISP1, I've got 2 peering connections to it. One in my New York City PE device, one in Denver, and I'm accepting a series of routes from both of them, and they want to load balance selectively across these 2 exit points. They want control on how I'm sending traffic to them. In this example, they have a /16, 14.1/16, and they want to send me any prefix that's under that /16 of any arbitrary length for load balancing purposes. So this is what they'd like to send me. I'm currently blocking all of these, but I want to make sure that I'm blocking them. So let's run some queries that allows me to understand what my current policy posture is. So I've got a series of prefixes they're sending me. I'm currently not accepting any of them. So again, this is some wrapper code that I wrote for some underlying Batfish functions that shows you, whether these prefixes are being accepted or not. So I can verify that these are not accepted. So now let's propose a change and see what a change would look like to accept these prefixes. So I'm going to change that input routing policy across all my PEs towards ISP1, so both PE1 and PE3. And so this is what the change is going to look like. So the thing I'm going to point out here is PE1 is, in my example, a Cisco iOS device, and PE3 is a Juniper device. So same underlying infrastructure, vendor agnostic queries allows me to sort of analyze both of these platforms at the same time. So what I've done here, I've sort of enumerated, okay, I want to, for anything that's under 14.1/16 up to /32, I'm going to permit that. I'm going to set my community when I accept it. And I updated my prefix, my policy. Same thing on the Juniper box. I've added a new term in my policy statement so that I can accept these /24s. So let's take a look at some of the routes, what I see in the network. So now, after that change, I can see, and I'm only showing you a subset of these, not all of them. I can see that these routes are being accepted on PE1 and PE3. So that's good. So that was sort of what I wanted to do. I can also now let's look at the general routing table. So another way I can compare it is rather than just looking at the snapshot, the new snapshot in that routing table, I can compare the routing tables. So everything I'm doing here, I can run differentially. So in Batfish, I can ask it to show me the difference between the routing tables, between the change I'm about to make and the snapshot that's running in my network. And so here I can see a series of changes. And what this is telling me is these prefixes are only in my snapshot. So I only see them in the new snapshot I created. They're not present in what's running in the snapshot that's running in the network today, which is sort of what I would expect. So I'm accepting, that's great. Let's see if I'm leaking anything. So here, now I can see I'm leaking these because I'm sending these routes out of my network to my customers. And again, I can see that the entry presence key is telling me that it's only in that new snapshot, not in the old one. So I made a change to accept them, but I didn't prevent propagation outside of the AS. So I can now make another incremental change on top of that to see how I can accept them but block those from being leaked to the rest of the world. I'm going to analyze the policy difference between snapshot 1 and snapshot 2. Before I make the change, I want to understand more of what Batfish is telling me about the previous change. So I'm going to compare the two routing policies. I'm going to look at what routes were permitted. So the thing I see is I didn't deny any routes. So the change I made to accept the /24s didn't deny anything, which is again a good thing. Now I want to look at what was previously denied but's now permitted. So I can see a series of these longer prefixes under that 14.1 subnet /16 are being permitted. So previously was denied, now is permitted. And I've got some community values. It's coming in with a community, and then I'm remarking that to something else. And then let's see if there's anything that was permitted but no attribute changes. Nothing there, so that's good. So as a core construct, I know what that change is supposed to do. It's doing at least part of what I want it to do. So let's make another change to that and say, how do I now turn this into the final policy I really need? So I'm going to do another fork snapshot, where I'm going to upload just another incremental change. And here, you can see the incremental change is I'm basically going to add a no export community. Because I could go around and all my output policies basically block anything greater than a /24, or I could just say, you know what, my policy is I'm going to mark things that don't need to propagate with a no export, and I'm going to make sure, and then the BGP, native BGP policy and all the vendor platforms will take care of it. It won't export anything outside of my AS. So same thing, I do that in Cisco and Juniper. And now let's see if anything's being leaked. So I'm going to run that get leak query, and then now I see the route presence is only in reference. So it's only in the previous snapshot, it's not in the current snapshot, so that's good. So I prevented that from leaving my network, which is what I wanted to see happen. But let's make sure that I'm still accepting it and propagating it within my network. So I'm going to do that again by just analyzing that policy using those core constructs. So I'm going to take my two test snapshots, I'm going to compare the BGP policies. So let's look at any new routes that were previously permitted, now denied. Nothing there. Now I can easily look at what are my newly permitted routes. Is anything that's previously permitted by the policy denied but are now permitted? I don't see anything there. What I expect to see is just a series of attribute changes. So this is what I have. I see I've accepted a series of routes that are /24 or longer in length. And rather than just marking them with that community value, I'm adding my no export community as well. So I have 2 communities that are getting set, and that is how I'm preventing it from propagating outside of my network. And so this is how I know that this is a safe policy for me to push, and now I can deploy that in my network. All right. So hopefully this sort of gave you a sense of how you can use an open source tool like specifically Batfish to analyze your routing policy changes. I know it's a little fast and it's hard to look at code in a live demo, but everything you need to get started, it's easy to get started with Batfish. There's a Docker container that you can download from Docker Hub. The Read the Docs has instructions on how to get set up, how to install it. We've put out a number of tutorials for how do you interact with Batfish. Some very basic, from how do I get node properties to how do I test routing policies to how do I test ACL and filter changes. And then there's a set of YouTube videos that we've also put together to sort of help walk you through the setup process and the interaction process. And then obviously everything here, so this presentation plus all the code that I was showing you guys, example snapshots and configs, so you can run all of that by going to my GitHub repo. It's public for you to clone, download, and run. And you can sort of get a sense for how you could use Batfish, play around with it, and see how you could adapt it to your specific environment. The goal here was, can I give you some building blocks that you can use when you're making manual changes to routing policies, or if you have an automated infrastructure to make changes to your network config, to deploy changes to your network, you can sort of integrate Batfish into that automated workflow and get validation before you deploy. So last thing before I'll open it up for questions, I wanted to keep a lot of time for questions. There's a lot of ways you can reach us. We have an open Slack channel. So if you go to our GitHub site, there's a pointer to join our Slack channel. If you go to batfish.org, there's a pointer to join the Slack channel. But you can reach us in any of these means, open a GitHub issue, join our Slack, ask a question. There's a large community, not just us maintainers, but also our users and other contributors that are there to help answer any questions you might have around what platforms might be supported on Batfish, how you could use Batfish to solve different problems in your network as you're building your automation. So that is my last slide. I will open it up for questions. No questions? Too fast? Or everybody still awake? Caffeine after lunch? Hello.
Hi, Avi Friedman. I have a question. So
Yes.
You're looking at whether routes will be dropped. Do you have any thoughts or plans, or does it currently have ability to integrate and say what kind of traffic will be affected, or what kind of volume of traffic will be affected by that?
Great question. So we don't do volume analysis. So because Batfish is offline and it's just understanding your configs, it can tell you what the reachability matrix is going to look like. So you can run a series of queries to say, show me flows that were previously permitted that are now denied, or flows that were previously denied that are now permitted. And you can build a reachability matrix to say who's affected. But we're not ingesting any SFlow or NetFlow data or any telemetry to see what volume of traffic would get impacted. But in terms of endpoints or services, you can absolutely understand what's the impact to the potential traffic in your network.
So is that when you think about a flow that'll be accepted or denied, is that 32 or 64 or 128, or is it the prefix at the prefix length as specified in the routing table to some other prefix at that prefix length?
So you can look at it from, hey, if I specify a series of input sources, so this is the boundary of my network, show me all flows that enter here that were previously accepted but are now denied. So what that will do is it will take a combination of what routes you're sending out those interfaces to your peers, so your prefix space or your header space, whatever it might be, and tell you what part of that traffic is impacted by this change.
But if it's 0/0 on the other end, are you projecting sort of across an internet routing table?
So yes, we can. So depending on how much of the internet routing table you feed into it, we can factor that into the header space as well. So the flip side of it would be, if you have the internet routing table coming over a peering connection, we will use that as the source address space for flows and tell you, okay, what is the source address space matrix with your destination space, which is your network prefixes, and tell you what flows are impacted.
Okay, so all potential. So like, 38/8 is one of the routes to all my potential. Then if I make a routing change, I don't know that I had traffic from there, but I'd see that I could no longer send
Exactly.
based on that. Okay,
Yeah.
cool.
So yeah, Batfish won't know if there was traffic there, but it'll tell you theoretically if traffic was coming in there, is that going to still happen or is it going to get denied or dropped?
Cool. What's the router vendor that you get most asked for that is not yet, you don't have the translation yet?
It's the most common one. So we have all the big ones. So Arista, Cisco, all the different flavors of Cisco, iOS, XE, XR, NXOS, Juniper. We've added Cumulus recently. We get a few requests for some of the older Dell boxes. It's come up a couple of times. Had a couple of users ask for Brocade.
ProCurve, MicroRouter.
ProCurve has not shown up that much. MikroTik every once in a while, but not mostly for if you want to add management layer analysis. But
Cool stuff. Thanks.
thanks. Awesome. Anybody else? Any questions? All right. There's nothing else. I think I'll give everybody about 14 minutes back to stretch their legs before the next presentation. Thank you very much.